So hello, everyone. Thanks for attending the demo day. I am Saeed, and I'm an applied ML intern at the Vector Institute. And I'm going to discuss the project that I've been working on since September, which is about prompt engineering for large language models. This is a work done with the help of our LLM group, advised by David and Faiza, and also our co-intern Jacob, which will present next. So like earlier today, we had a presentation about providing large language models as a service at the Vector Institute. And now this project is more about the application of using large language models if we want to kind of train them on any like downstream task. Specifically, this project is about like natural language processing tasks. And recently in the research of NLP, prompting is a technique to use these large language models and update few number of parameters if we want to train them and use them on another NLP task. So prompting is basically the process of using carefully crafted phrases or templates to construct a model input text to help the pre-trained language model to accomplish a downstream task. For example, if you want to do a sentence classification, we have a review from, I don't know, about the movie, or in this case, I guess about the customer service. So the input is that I love this customer service, and sentiment is a positive sentiment. If you want to fine-tune or train a language model on this data, you have the input, you have the output, you feed it into your model, and then you kind of update every parameters of your model. But the prompting, the idea is that we will augment the input with some instructions or what we call the prompts. And then we're going to change like very few parameters in the large language model. And then we expect the same output or our desired output in the output of the large language model. So my internship in a nutshell, so it's divided into 3 months, I would say. The first month, I was conducting literature review on prompt engineering. The second month, we decided to start with the best method, which is a soft prompt tuning method. And kind of I worked on providing a train and inference scripts to run that method on the Vector's GPU cluster. And the challenge was that this code base released by Google Research is implemented in JAX, which is a different, like a programming language and framework for machine learning models. And then also use some frameworks developed based on JAX, like T5X. So kind of the second month was about how to use that framework and code base, which is optimized for TPU, and then bring it and run it on GPU cluster in the Vector. And more importantly, since there's going to be a workshop or lab around prompt engineering at the Vector Institute, I was also working on providing reference implementations and kind of providing reference, like an easy reference implementation in PyTorch, which is widely used by researchers, and also implement other like baselines for prompting, such as like full model tuning or other like baselines such as input output, like layer fine tuning. So I will discuss these like baselines in detail. So after reading, like 15 papers about prompt engineering, again, like if you go and scrape every conference in machine learning, there's going to be a paper about like prompt engineering. So it's a really hot topic. So after reading multiple papers, we decided to work on soft prompt tuning. The idea is that if we have input, here in this case a sentence, so your sentence has multiple words, what you usually do is that you encode or transform these sentences into a feature representation, basically assigning a feature vector into your, like for each of these words, and then you feed that feature vector into your model. In this case, we're using T5 models. The idea of sub-prompting is that we want to search for prompts in the feature space. So idea is that we assume that we have, like, let's say, T number of virtual prompts, and if we convert those virtual prompts into features, then we will end up having the 2D metrics. And the idea is that we just concatenate or pre-print that feature, like prompt metrics, into our original input metrics, and then we feed that into our T5 model. So I'll go into details of this with some illustrations. So here we have the T5 model, which is like a encoder-decoder transformer model. It has like multiple blocks of transformer layers. And so the idea of prompting is so simple. If we have input, we convert input into embeddings. The idea of prompting is that we have an extra embedding metric, like embedding metrics, in this case prompt, and we just prepend that into our main embedding metric. And then we train kind of only the prompt metrics on the downstream task. And in this case, for example, if you use T5 large, we're only updating this many number of parameters, like 50 times 1,024 parameters. So the other so before describing the other baselines, why the sub-prompt tuning is good, because it can actually outperform GPT-3 with 175 billion parameters, because GPT-3 uses like some manually designed instructions and some input-output examples, but the original paper that suggests sub-prompt tuning shows that it can outperform GPT-3. So in this figure, GPT-3 is this blue curve, and sub-prompt tuning is this green curve. It can outperform GPT-3. And also, as we scale the models, as we're using larger and larger models, sub-prompt tuning can catch full model fine-tuning. So this is the work that I've been working on in the second month of my internship, which was, as I described, like running that release code base for sub-prompt tuning on the Vector's GPU cluster. We tried it on a sentiment classification task, which had only 2 labels, positive and negative, and we could successfully train it on the Vector's GPU, although the original code base was designed for TPUs. Now, in terms of the baselines, so I mentioned that to provide kind of reference implementations, we decided to implement like these like prompting techniques in PyTorch, and also provide some other baselines. So one of the baselines that one can use is just updating the input embeddings, and it corresponds to these 2 blocks here. And in that case, you're using this many number of, you're training this many number of parameters, which is like bigger than the number of parameters that you need with prompting. Also, another baseline could be just feeding the input, but only changing the language modeling head in the T5 model. And it has the same size as the input embedding metrics. So again, you're updating a lot of parameters. Another, baseline is just updating everything in your model. So in that case, if you're using T5 large, you need to update like 770 million parameters, which is not feasible, especially if you want to provide large language models as an API to a larger community. They cannot update the model because it's time consuming and it's just not feasible. And for classification, there could be other baselines. In this case, we could just build a discriminative classifier over just one part of the model. In this case, we can introduce a small classifier with few number of parameters, and just like build the classifier exclusively instead of trying to learn like a generative approach for classification. So with this T5, for example, in the sentence classification, we feed in the sentence, and the output, we're actually generating the name of the class. So that's a generative approach for classification. But an easier approach would be maybe just building a classifier itself and moving away from the generative approach. So now we have like these soft-prompt tuning method and then 5 other baselines. And one thing that we noticed with our implementation and also our experimentation, we noticed that we have to search for the hyperparameter for each of these methods. And luckily, like we have very good amount of GPUs at the vector, and we could actually search for the optimal hyperparameter successfully with this number of GPUs that we have at the vector. So to verify that our implementations are actually working, here we have a comparison between these baselines. The y-axis is the accuracy on the validation data, and the x-axis is the number of training steps as we train these baselines. And as we see at the top, we have the soft-prompt tuning, which actually kind of outperforms the other baselines here. We have, for example, classifier fine-tuning, and also it performs the same as the full model fine-tuning. So this is a kind of a reason why people prefer prompt tuning, because you update very few parameters, but you actually gain like very good performance. So the next step for us is that we will also implement other reference implementations. So we started with self-prompt tuning, which is kind of the best method, but other techniques are in the area of discrete prompting, where we search for some like words in the vocabulary, like some atomic words that can be added into your input, and it can prompt the language model to kind of your desired output. So we're going to also provide other like baselines. Also, with T5 models, again, research shows that T5 can be better than GPT-3 with 175 billion parameters. It would be great if we can like host larger T5s, but currently in this experiment, like in this experiment, I could only use T5 large, but probably it's possible that we can use a multi-host, multi-GPU framework in PyTorch and host larger TPUs. Because again, the research shows that prompt tuning converges to full model tuning if we use larger models. And also we can experiment with other tasks, such as like affect-based sentiment, and also run any task that could be interested for the sponsors. And this is the link to our repo. Thank you.
Hey, Saeed. So towards the beginning of the presentation, you showed how you had trained T5 large with prompting and that you beat GPT-3 175. And I was curious how you measured this. You measured on the side there a superglue score. What's that? What does that mean?
Thanks for asking. I would say that this is not my experiment. So this is actually the paper proposing self-prompting. So this figure is from that paper. I just kind of refer to that paper just to prove that like self-prompting is working. But I guess for different model parameters, so each of these models, they have different variants. Like in case of T5, we have T5 small, T5 base, T5 large, T5 with 3 billion, T5 with 11 billion. So kind of they've done this experiment for all of these different models, and they've plotted this figure.
Going back to the same evaluation. Sorry, going back to the same evaluation. So this super glue score, I'm not super aware of what this actually measures. It's like what data set is it actually evaluating on, and like what is it measuring, this particular metric?
Sure. The superglue is again, I'm not sure, but it's an 8 different NLP tasks. Like one of them is sentence classification. The other ones are like, for example, detecting sentence duplication or detecting question duplication. So it's a combination of 8 tasks, and usually the scores are accuracy or response. So this is like a merged score.
In your opinion, because as you may know, we are going to have this project on prompt engineering, and probably my question would be, what do you think will be the most challenging part for them to adopt this idea? Because this is probably one of the projects that I believe are kind of ahead of the curve kind of thing, and that requires a lot of understanding of how these things work. And eventually, if you see these people trying to adopt this technology, what do you think is going to be the hardest thing for them to understand, to grasp?
Sure. So I guess we're trying to solve one of the obstacles, which were moving away from JAX and the new libraries built in JAX, because not a lot of, I would say, like machine learning engineers in the industry, they're familiar with JAX. So that's why we're trying to like provide the implementations in PyTorch. So that would kind of simplify the concept for them. And also even with the PyTorch implementation, we're using some reference implementations for T5 from like HuggingFace. So we should assume that the participants, they're familiar with HuggingFace, and they're also familiar with PyTorch, and generally they're familiar with like some model architectures, like in this case, the T5. So we should assume that they are familiar with these kind of.
Just keep that in the expectations for the participants, because those assumptions sometimes they don't have that. Just letting you know.
Yeah, that's something that I guess in the LLM groups, I guess the other team members maybe we can discuss, and probably they'll provide more comments about that.